Good morning, chemistry students. Today we're going to talk about molecular compounds, and I thought we'd start off with looking at a list of compounds behind me here and discussing what we already know about each one. So looking at the list, they all look very similar when you write them as a formula. When you look at the names, you might notice something unusual though. You might notice that some of them have prefixes. Those are the Greek prefixes that we've talked about. And others don't have prefixes. And again, you should remember that the reason that they do or don't have prefixes is because some of them are ionic compounds and some of them are molecular compounds. The way you know whether you have an ionic or a molecular compound is by determining whether or not the first element in the compound is a metal. So here we have sodium and oxygen and hydrogen. Sodium is a metal, oxygen and hydrogen are not. Let me show you how I know sodium is a metal. Of course, you look on your periodic table. So everything from this line over, except for hydrogen, is a metal. And everything to the right of the line is a nonmetal. So here's sodium. Sodium's a metal. So this is going to be an ionic compound. Calcium is here. It's a metal, so this is an ionic compound as well. Magnesium is a metal, so this is ionic. Carbon is a nonmetal, so this is a molecular compound. And calcium is a metal, so ionic. Calcium again, ionic. And we could do the same on the list over here. I'll do these real quick. Sodium is ionic, makes it ionic because it's a metal. Carbon is a nonmetal, molecular. Phosphorus is a nonmetal. And those look like that. Now we also learned to classify these according to whether they're binary or ternary for the ionic compounds. So you look for the number of elements to determine whether it's binary or ternary. 2 elements means that it's binary. This one is going to be ternary because we have 1, 2, 3 elements. You know oxygen and hydrogen are not one element together because they're both capital letters. This has 3 capital letters in it, so this is a ternary ionic compound. When you get to the names, it's a little bit tricky because for the names, you have to look at the endings. There's a couple things you have to memorize. Like, for example, the 8 ending tells us this is a ternary ionic compound. If it's got an "ide" ending and it's not hydroxide or cyanide and it doesn't start with ammonium, then it's binary. So there's some rules you got to memorize here. Molecular compounds, you don't worry about binary or ternary. Magnesium fluoride is going to be binary. And we'll finish these up over here. This is binary because sodium and chlorine are 2 separate elements. This is ternary because we have 1, 2, 3 elements. Moleculars, you don't worry about it. This has 1, 2, 3 elements, that's ternary. And this has only 2 elements, so that's binary. So now we're going to talk about how we go from the name of the compound to the formula if it's molecular, or from the formula to the name. Okay, so here's your notes on molecular compounds. So this is molecular compounds for chemical nomenclature. Molecular compounds, as you should already know, are formed from 2 nonmetals. They don't form because of charges. They form because they're covalently bonded together. They're sharing valence electrons so that each atom has an octet. So we will ignore the charges that the elements can form. Don't worry about that at all. Let's see. To use the formula of a molecular compound and write the name, we're going to use a prefix to indicate how many atoms of each element are in the compound. Then we use the name of the element, but we change, and we do that for both elements. Then we change the ending of the last word to be ide, I-D-E. So we might have bromine, we'll change it to bromide. Here are the prefixes. I think we've gone over these before. You might have noticed I had some Tetris pictures on the first slide. Let's go back and look. There they are. It looks like the game Tetris. Hopefully you're familiar with that. If you notice, each of the little blocks that falls down from the sky has 4 smaller blocks that it's composed of. So you've got 4 blocks here, 4 blocks in a T, 4 blocks in a line, 4 blocks in an L. Well, it's always 4, and tetra is the prefix for 4. That's the one that students kind of commonly confuse. They want to say quadri or something like that, which kind of makes sense and would be reasonable, but that's not what we use. So here we go. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, and 9 is nana or nona, you can pronounce it either way, and 10 is deca. So you do need to memorize these. They're pretty easy, but it's something you need to write down and make sure you know. So if you want to pause the video right now and write those down, I think it would be a good idea. There are some exceptions to the rules for how we do this. The first one is that we don't write mono on the first word. So if there's only one of the first element, we just say the element's name. So for example, CO2 is carbon dioxide. Lots of kids want to call it monocarbon dioxide. Well, the dioxide part makes sense because it's 2 oxygens, but carbon on the first word, we would not put mono because it's the first word. The second exception is that we drop the O or the A from a prefix if the next letter is a vowel. Now let's go back to those prefixes and see when that's going to happen. Oops, here we go. Here's an O, mono. Di and tri, we're not going to drop any letters, but tetra, penta, all of the ones that end in A or O, we're going to drop those letters. So we drop the O or the A from a prefix if the next letter is a vowel. So CO is carbon monoxide, not carbon monoxide, especially because that sounds a little strange, but it looks really strange. It looks like it should be monoxide or something like that. And of course it's not. And CI4 is carbon tetraiodide, not carbon tetraiodide, carbon tetraiodide. But CI3, the prefix tri, doesn't end with an A or an O. So we keep the whole thing. We don't drop any letters. So CI3 is carbon triiodide, which looks and sounds funny, but that's the tradition. So we drop the O or the A from the prefix if the next letter is a vowel, A, E, I, O, or U, and we don't write mono on the first word. So here are some sample problems. Let's try these. So we have diphosphorus pentachloride. So the formula is going to be the letter for phosphorus, which is P, and then a 2 for the di. They're sort of switched backwards. It almost seems like you should put phosphorus dichloride penta or something like that, but that's not the way it works. It sounds funny, I think. So diphosphorus is P2, pentachloride is Cl5, P2Cl5. So it looks like that. All of your numbers have to be down low, subscript numbers. You can't ever have them up high floating because superscript numbers indicate charges, and that's not what we're talking about here. In our next one, we have CBr4. So since carbon is a nonmetal, the first element's a nonmetal, it's molecular. So we have CBr4, so you might think it would be monocarbon and then tetra for 4, bromide. But of course, we don't put mono on the first word, so this is just going to be carbon tetrabromide. And it's 2 words, carbon tetrabromide. And our next one, oops, there it is. On our next one, we have C2Br7. I'm going to get this out of the way here. There we go. Oops, too fast. C2Br7, gave that one away. C2Br7 is going to be dicarbon, and then 7 is heptabromide. Dicarbon heptabromide, and there's that. And then we're going to have xenon hexafluoride. Now, xenon is a noble gas. It doesn't normally bond with anything, but we actually can force it to bond with fluorine in the lab. We do that sometimes. So xenon hexafluoride is going to be Xe. Now, since there's no prefix, that means there's just one of them. And then fluorine is F, and then hexa means 6. So XeF6. Oops, here it is. and that's xenon hexafluoride. Sounds pretty easy, and these are pretty easy. The molecular compounds are pretty simple. The only trick is you can't get the ionic and the molecular compounds confused. So again, molecular formula writing or name writing only works if the first element is a non-metal. If your compound starts with a metal, you got to use the ionic rules. And the ionic rules have no prefixes, and sometimes Roman numerals. So hopefully that has clarified, I think that's our last slide, yep. Hopefully that has clarified how to do writing molecular compounds for you. If you have any questions, I will be available in the WebEx pretty much every day for the next couple weeks. So come and visit if you're having trouble with any of this, or if you have any general questions about chemistry or science or whatever. I would love to talk to you. Talk to you later.